Close your eyes for a moment. Breathe slowly. Right now, somewhere in the vast darkness beyond our world, something ancient is traveling toward us. Something that has been wandering through space for billions of years. A visitor older than our own sun. A messenger from the time when stars were still learning to shine. This is the story of 3I Atlas, a comet that defies everything we thought we knew about our cosmic neighborhood. It is not born from our solar system. It comes from somewhere else entirely, from another star, another world, another beginning that happened long before Earth existed. Welcome. Before we begin this journey together, I invite you to subscribe to the Relaxing Science channel. Give this video a gentle like and share with us where you are listening from right now and what time it is in your world. Your presence here matters. The discovery of interstellar visitors like this one teaches us something profound. We are not alone in the universe. We are not isolated. Our solar system is not a closed garden. It is a place where travelers arrive, where ancient stories are written in ice and rock, where the cosmos speaks to those who listen carefully. Imagine standing beneath a night sky, looking up at the stars. Most of what you see belongs to our Milky Way galaxy. But occasionally, very occasionally, something passes through. Something that does not belong to the sun's family. Something that traveled here from unimaginable distances, carrying secrets from worlds we will never visit. This is exactly what happened when 3I Atlas arrived, the third interstellar object ever detected, the third visitor from beyond. Before this comet, there was Oumuamua in 2017, an object so strange that scientists are still debating what it truly was. Then came Comet Borisov in 2019. And now, 3I Atlas joins this exclusive group of cosmic wanderers that have crossed into our solar system's territory. But what makes this particular visitor so fascinating? Why should we pause and listen to its story? The answer lies in what it is made of, in the ancient light it reflects, in the chemical whispers it carries on solar winds, in the trajectory it follows through space. A path that tells us exactly where it came from and why it arrived here now at this precise moment in time. Scientists around the world have pointed their most powerful telescopes toward this comet. Observatories in space, instruments on mountains, digital networks connecting researchers across continents, all focused on one question. What can this ancient wanderer teach us about the universe beyond our sun? The answer is extraordinary. This comet carries information about planetary formation in distant star systems. It holds clues about how planets form around other suns. It reveals the chemical recipe that exists in other parts of the galaxy. It is, in essence, a time capsule sent by the cosmos itself. When we study 3I Atlas, we are not simply observing a rock moving through space. We are reading a book written in the language of chemistry and physics. Every molecule tells a story. Every atom is a word in a cosmic narrative that spans billions of years. This comet has traveled through the darkness for longer than human civilization has existed. It has passed through regions of space where no human eye has ever looked. It has survived the radiation of distant stars, the gravitational pulls of invisible planets, the endless cold of the void between worlds, and now it is here, moving through our solar system. A temporary visitor passing through our neighborhood before it continues its eternal journey into deeper space. The path it takes is not random. It follows a hyperbolic trajectory, a mathematical curve that tells us it came from somewhere specific. Scientists can trace this path backward, like reading footprints in snow to discover where this comet originated. What star system sent it? How long ago did it leave? What caused it to wander into our cosmic territory? These are the questions that keep astronomers awake at night, their eyes fixed on telescopes, their minds working through calculations and data. These are the mysteries that remind us how much we still do not know about our universe. But beyond the science, there is something deeply poetic about this moment. We live in an age where we can detect objects coming from other star systems. We have developed the technology, the mathematics, the sensitivity to notice when a stranger arrives from the cosmic frontier. We can read messages written in molecules. We can understand the language of the universe. This comet is a gift, a reminder that we are part of something vast and interconnected, that our solar system is not isolated. that the universe is alive with movement and change and constant arrival and departure. As this ancient visitor passes through our neighborhood, it brings with it stories from billions of years ago. Stories of how planets form, stories of how chemistry works in distant places, stories of the interconnectedness of all things. In the moments ahead, we will explore what makes this comet so special. We will examine its chemical composition, the molecules that make it up, the light it reflects. We will trace its trajectory, understanding the mathematics of its journey. We will connect the science with something deeper, something that speaks to the soul. We will learn how scientists detect these visitors, what tools they use, how they read the data, how they translate the language of light and radiation into understanding. And through all of this, you can allow yourself to relax, to breathe, to let your mind wander through the vastness of space while your body remains still and calm. This is the gift of contemplating the cosmos. The universe has a way of quieting our worries, of putting our daily concerns into perspective. When we look at something 7 billion years old, something that has traveled across the galaxy, we begin to understand that our problems are small. Our anxieties are temporary. Our place in the cosmos is both insignificant and sacred. This is the journey we begin now, a journey through space and time, a journey through science and wonder, a journey that will help you relax, to think deeply, and to feel connected to something greater than yourself. The ancient comet waits for us. The story is ready to be told. The universe is ready to share its secrets. Let us begin. When light touches matter, it tells a story. As 3I Atlas drifted closer to our sun, telescopes across Earth captured something extraordinary, the chemical fingerprint of a world born in another star system. Every element has a signature. When sunlight passes through the comet's atmosphere, what scientists call its coma, certain wavelengths disappear. These dark lines, called absorption spectra, reveal which molecules float within that ancient cloud of dust and gas. It is like reading the autobiography of time itself. The first surprise came from water. Not ordinary water as you know it, but water molecules that carry isotopic markers from a distant stellar nursery. The ratio of hydrogen to deuterium, a heavier form of hydrogen, differs from what we find in our own solar system's comets. This difference is subtle yet profound. It whispers of a birthplace billions of kilometers away, where different physical conditions shaped matter into unique combinations. Imagine standing in a vast library where each book represents a different world. The arrangement of letters, the isotopic ratios, tells you which library each book came from. 3I Atlas carries pages written in an unfamiliar dialect. Organic molecules emerged from the spectroscopic analysis as well. Carbon monoxide, carbon dioxide, and complex hydrocarbons floated within the coma. These are not alive, yet they are the building blocks from which life emerges. In the cold darkness between stars, these molecules assembled over millions of years, frozen into structures that survived the journey across interstellar space. The presence of cyanide compounds particularly fascinated researchers. On Earth, cyanide carries connotations of danger, yet in space, these same molecules are neutral ingredients in the cosmic recipe. They represent chemistry unfolding without the interference of life, without the bias of terrestrial biology. They show us how matter organizes itself in the vast emptiness beyond any sun's warmth. Scientists used spectroscopy, the art of reading light, to decode these secrets. Specialized instruments aboard observatories separated incoming light into its component colors, revealing which wavelengths the comet absorbed. Each absorption line corresponds to a specific molecule, a specific element. The data accumulated like pages in a journal, each page adding texture to our understanding. The dust particles surrounding the nucleus told another story. These grains, measuring mere micrometers across, carried their own chemical composition. Some contained silicates, the same minerals found in rocky planets. Others held metals like iron and nickel. The mixture suggested formation in a protoplanetary disk, a swirling cloud of material orbiting a young star, the same kind of disk that birthed our own planets billions of years ago. But here is where contemplation deepens. The chemical composition of 3I Atlas suggests it formed in a stellar system with different conditions than ours. Perhaps the star was more massive, burning hotter and faster. Perhaps the planetary disk extended farther from the star, remaining colder for longer periods. Perhaps gravitational interactions with forming planets ejected this comet into interstellar space, where it wandered alone for eons until our sun's gravity finally captured it. The molecular abundance ratios provide clues about temperature. When a comet forms, different molecules freeze at different temperatures. By measuring which molecules are present and in what quantities, scientists can estimate the thermal history of the comet's birthplace. It is like examining tree rings to understand past climates, except these rings are written in chemistry. What fascinates researchers most is what remains unknown. Some molecules detected in the coma have not yet been fully identified. Their spectral signatures do not perfectly match any known compound in laboratory databases. This suggests either entirely new molecules exist in space, or known molecules exist in unexpected configurations. The universe, it seems, still holds surprises. The study of 3I Atlas has already influenced how astronomers think about interstellar chemistry. Previous interstellar visitors, the first two objects of this type, were studied less thoroughly. Technology has advanced. Telescopes have multiplied. Our instruments now capture details that would have been invisible merely a decade ago. Consider the implications. If this comet carries molecules from another star system, then other star systems carry molecules from yet other systems. Chemistry flows across the galaxy like currents in an ocean. Matter mixes and redistributes. The very atoms in your body may have journeyed through dozens of star systems before settling here on Earth. The spectroscopic data also revealed something about the comet's activity. As it approaches the Sun, solar radiation warms the frozen surface. Different materials evaporate at different rates. Water ice sublimates first, creating the visible coma. Dust particles scatter sunlight, creating the faint glow that telescopes detect. The rate of outgassing, how quickly material escapes, tells us about the internal structure and composition. Scientists observed that 3I Atlas released more carbon monoxide than expected for its size. This suggests either a higher concentration of carbon monoxide in its nucleus or a more active surface responding more dramatically to solar heating. Either interpretation adds nuance to our understanding of how interstellar comets differ from local ones. The chemical analysis continues as 3I Atlas moves through our solar system. Each observation, each spectrum, each measurement refines our knowledge. The comet remains a messenger, still delivering information across the void. Where are you listening from and what time is it there? I wonder if you are watching these words on a quiet evening, letting them drift through your mind like this ancient visitor drifts through space. The story of 3I Atlas is far from complete. We have read its chemical autobiography, but we have not yet traced its path. That journey through space holds its own mysteries, its own revelations about the nature of motion, gravity, and the invisible geometry that shapes the cosmos. Imagine a path drawn across the cosmos. Not a straight line, but a curve that bends and flows like water around an invisible stone. This is the journey of 3I Atlas, and understanding how it moves tells us something profound about the universe itself. When astronomers first tracked this visitor, they noticed something unusual. The comet was not following the gentle elliptical orbits we see from comets born in our own solar system. Instead, its trajectory was hyperbolic. This single word, hyperbolic, carries enormous meaning. It means the comet is not trapped in a loop. It will not return. Think of it this way. Most comets orbit our sun like children on a merry-go-round, returning again and again. But 3I Atlas is different. It entered our solar system from the depths of interstellar space, and when it leaves, it will never come back. The mathematics of this path reveals that this visitor arrived with tremendous speed and will depart with equal momentum. The hyperbolic trajectory is not random. It is a signature. It tells scientists that 3I Atlas was born elsewhere, ejected from another star system by forces we can only imagine. Perhaps a collision during the formation of a distant planetary system sent this ancient traveler careening through the void. Perhaps the gravity of a massive star pulled it away from its birthplace. Whatever the cause, the mathematics of its path is absolute and undeniable. When you measure the velocity of an interstellar object, you measure its history. 3 Atlas arrived in our solar system, moving at approximately 46 kilometers per second. That is not the speed imparted by our sun's gravity alone. That is the speed it carried from another star, from another world, from another sun that died or evolved billions of years ago. Scientists use a calculation called the excess velocity. This number represents how much faster an object is moving than our sun's gravity could explain. For 3I Atlas, this excess velocity is significant. It confirms what the chemical composition already suggested. This comet belongs to another star system. It is a messenger from a distant neighborhood of the galaxy. Now here is where the poetry meets the mathematics. The hyperbolic path means that 3I Atlas is on a one-way journey through our cosmic neighborhood. It will swing around our sun, and then it will venture back into the infinite darkness from which it came. Somewhere in the future, perhaps millions of years from now, another star system might receive this wanderer. Another civilization, if one exists there, might look up and wonder about this strange visitor from their perspective. The trajectory also reveals timing. Astronomers can calculate backward, tracing the comet's path to determine where it came from. The data suggests 3I Atlas originated from the direction of the Lyra constellation. This is not a precise address, but rather a general direction, a cosmic compass pointing toward its home. Somewhere in that direction, 7 billion years ago, this comet formed around a star whose light may have already faded from existence. What makes hyperbolic trajectories so significant for science is what they tell us about the universe's structure. Our solar system is not isolated. It is embedded in a galaxy with billions of stars, each with its own planetary systems. Objects are constantly being ejected from these systems. Some are planets torn away by gravitational encounters. Some are comets like 3I Atlas, cast adrift by stellar collisions or the chaotic dance of young planetary formation. The universe, in this sense, is not static. It is alive with motion. Objects travel between stars like seeds on the wind. When one of these seeds reaches our solar system, it carries information about its origin. The hyperbolic path is like a delivery note, telling us exactly where this package came from and how fast it traveled. As 3I Atlas approaches its closest point to our sun, its velocity increases further. The sun's gravity accelerates it, much like a stone dropped from a cliff accelerates as it falls. But this acceleration does not trap the comet. Instead, the sun's gravity acts like a mirror, reflecting the comet back into space at an even higher speed. The comet uses our star like a cosmic springboard. This reflection is crucial. It means that by the time 3I Atlas departs our solar system, it will be moving faster than when it arrived. The energy it gained from our sun's gravity will propel it toward yet another star system, perhaps one we have never observed, perhaps one that harbors life forms we cannot imagine. The hyperbolic trajectory also teaches us about detection and discovery. For decades, astronomers wondered if interstellar objects visited our solar system. The mathematics suggested it was possible, even likely. But until 3I Atlas and its predecessor were observed, these visitors remained theoretical. Now, with modern telescopes and detection systems, we can identify them. We can measure their paths. We can begin to understand how common such visitors truly are. Consider this moment of contemplation. Right now, as you listen, countless objects are traveling through interstellar space. Some are heading toward our solar system. Some are leaving it. Some will arrive thousands of years from now carrying secrets from stars we have not yet discovered. 3I Atlas is simply one of these travelers, one that happened to pass close enough for us to notice. The hyperbolic path represents freedom and constraint simultaneously. The comet is constrained by the laws of gravity, by the mathematics that governs all motion in the universe. Yet it is free to travel anywhere, to visit any star, to explore the entire galaxy across timescales that dwarf human existence. This is the paradox of cosmic motion. Everything follows precise rules, yet everything moves in patterns of infinite complexity and beauty. Now, let us pause and imagine something profound. This visitor did not simply appear in our cosmic neighborhood by accident. Every atom within this ancient comet tells a story that began not here, but in the cradle of a distant sun, billions of years before our own planetary system took shape. When astronomers first analyzed the light reflected from 3I Atlas, they discovered something remarkable. The chemical fingerprint was different, not wrong, not alien in a way that defied understanding, but distinctly foreign. The ratios of carbon to nitrogen, the presence of certain organic molecules, the subtle variations in ice composition, all pointed to a formation environment unlike anything we find in our local solar system. Think of it like this. When a child is born, they inherit traits from their parents. Similarly, when a comet forms around a star, it inherits the chemical signature of that stellar neighborhood. The materials available, the temperature, the density of the forming disk, all these factors leave permanent marks on the comet's composition. 3I Atlas carries these marks like a cosmic passport, revealing where it truly originated. Scientists believe this object formed in a stellar nursery near the constellation Lyra, approximately 7 billion years ago. At that time, our solar system did not yet exist. The sun was still gathering material from the cosmic dust. Earth was not even a thought in the universe. Yet somewhere around another star whose name we may never know, planets were forming. And alongside those planets, countless comets were being born in the outer regions of that distant system. The star that gave birth to 3I Atlas was likely similar to our sun in many ways, yet different in crucial details. Perhaps it was slightly more massive, perhaps it rotated faster. The composition of its surrounding disk might have contained slightly different proportions of heavy elements. These small differences, multiplied across billions of years, create worlds and objects fundamentally unlike our own. What makes this discovery so calming to contemplate is the realization that our solar system is not unique. We are not isolated. The universe is filled with countless stellar systems, each with its own collection of comets, asteroids, and planets. Each system is a world unto itself, yet all are connected through the same physical laws that govern everything from the smallest atom to the largest galaxy. As you sit with this knowledge, consider what it means. The atoms in your body were once part of a star. The iron in your blood, the calcium in your bones, all forged in stellar furnaces billions of years ago. Now, a comet from another star system drifts through our cosmic home, and we can study it, learn from it, understand it. We are not separate from the cosmos. We are part of it. The formation context of 3I Atlas reveals something deeper about planetary birth itself. When astronomers observe this comet's composition, they gain insight into how planets form around other stars. They learn what materials are available in distant systems. They understand what conditions might support life elsewhere. In studying this ancient visitor, we are not merely cataloging a space rock. We are reading a chapter from the book of creation itself. The temperature at which 3I Atlas formed was likely quite cold, much colder than the inner regions of our solar system. This is why its ice composition is so distinctive. The frozen volatiles trapped within it, carbon dioxide, methane, water ice, all froze at specific temperatures, creating a permanent record of its birthplace. When scientists measure these frozen materials today, they are essentially reading a thermometer that has remained frozen for 7 billion years. Now, let me ask you something as you absorb this information. Where are you listening from right now? What time is it where you are? I'd like to know. Share your location and time below. This simple act connects us, reminds us that we are all here together on this small planet, contemplating the vastness of creation. The journey of 3I Atlas from its birthplace to our solar system is a journey through time itself. Imagine the billions of years this object has traveled through the darkness of space. It has witnessed the birth and death of stars. It has passed through regions of space we may never explore. It has carried its chemical secrets across distances so vast that human language struggles to describe them. Yet here it is now, close enough for our telescopes to observe, close enough for our spectrographs to analyze, close enough for us to learn from it. This is not coincidence. This is the universe offering us a gift, a messenger from another stellar system, arriving at precisely the right moment in our technological history when we can understand its message. The significance of understanding 3I Atlas's origin extends beyond mere curiosity. It shapes how we think about the universe. It challenges our assumptions about isolation and uniqueness. It reminds us that we exist within a larger community of worlds, a cosmic neighborhood where objects migrate and interact across incomprehensible distances and timescales. As this ancient comet continues its journey through our solar system, it carries with it the memory of its creation. That memory is written in chemistry, in the arrangement of atoms, in the structure of molecules. Our scientists are learning to read this language, and as they do, they reveal not just the history of 3I Atlas, but the history of creation itself. The cradle in which 3I Atlas was born no longer exists. That distant stellar system may have evolved dramatically over 7 billion years. The star that birthed this comet may have transformed, expanded, or even exploded, yet the comet endures, unchanged, a frozen monument to a world that exists now only in the past. This is the profound gift of studying ancient objects. They allow us to see not just what is, but what was. Now that we understand where this ancient visitor was born, we must ask ourselves a deeper question. What makes 3I Atlas fundamentally different from the countless comets that orbit our own sun? The answer lies not in a single characteristic, but in how all its qualities converge into something truly exceptional. This is the moment where science reveals a profound truth about our place in the cosmos. When astronomers first identified 3I Atlas among the stars, they noticed something unusual. Most comets in our solar system follow elliptical paths, returning predictably year after year, century after century. They are bound to our sun by gravity, prisoners of a celestial orbit established billions of years ago. But 3I Atlas moves differently. It passes through our solar system like a traveler passing through a foreign city, never to return. This distinction matters profoundly. An elliptical orbit means permanence. A hyperbolic trajectory means freedom, but also finality. 3I Atlas will never circle back. Once it leaves our sun's gravitational influence, it will continue into the infinite darkness, perhaps never encountering another star system again. In this way, it embodies the loneliness of interstellar space itself. Consider the composition we discussed earlier. The isotopic ratios found in 3I Atlas tell us something remarkable. Certain isotopes appear in proportions that do not match what we find in our own solar system's building blocks. Isotopes are variants of the same element with different numbers of neutrons. They form under specific conditions at specific temperatures within specific stellar environments. The ratios we observe in 3I Atlas suggest formation in a stellar system with different radiation patterns than our sun. Perhaps its parent star was more massive, burning hotter in its core. Perhaps it was younger when 3I Atlas formed, or perhaps the system contained different proportions of heavier elements. Each possibility tells a story about another world, another sun, another place where planets might have formed and life might have emerged. This is what makes 3I Atlas stand apart from other visitors. We have detected other interstellar objects before this one. The first, 1I Oumuamua, arrived in 2017, moving through our solar system like a ghost, leaving behind questions that still puzzle astronomers. The second, 2I Borisov, arrived years later, a comet that showed signs of outgassing as it approached our sun. But 3I Atlas carries something different. Its chemical signature is more complex, more varied, more indicative of a truly alien origin. The organic molecules trapped within its frozen nucleus speak to processes we recognize yet do not fully understand. Carbon compounds, hydrogen-rich ices, silicates, and trace metals all exist together in this ancient traveler. These are the same basic ingredients that formed our own solar system, yet combined in different proportions, frozen under different conditions, shaped by different stellar winds. Imagine the journey this object has undertaken. 7 billion years ago, it formed in a protoplanetary disk orbiting a star near Lyra. It may have been ejected during planetary formation, knocked loose by gravitational interactions between young planets still settling into their orbits. Or it may have always been a wanderer, part of a vast cloud of cometary bodies surrounding that distant star, never destined to become part of a stable planetary system. For billions of years, it traveled through interstellar space, exposed to cosmic rays that slowly altered its surface. It passed through dust clouds, through regions of intense radiation, through the quiet emptiness between stars. Its trajectory brought it closer and closer to our solar system, an encounter that was not chance but rather the inevitable result of the cosmos's vast geometry. When 3I Atlas finally crossed into our solar system's domain, it began to warm. The frozen compounds at its surface started to sublime, transforming directly from ice to gas. This outgassing created the distinctive coma and tail that allowed us to detect it, to study it, to marvel at it. Without this warming, without this visible transformation, we would never have known it was here. What stands 3I Atlas apart is its role as a messenger. Every comet tells a story, every asteroid carries information, but an interstellar object carries a story from beyond our solar system, a narrative written in chemistry and trajectory, in isotopic ratios and molecular composition. It is a postcard from another stellar system, delivered across billions of years and billions of miles. The third interloper reminds us that our solar system is not isolated. Objects move between stars. Information travels across the cosmos. The universe is not divided into separate, sealed compartments, but rather exists as an interconnected whole, where matter and energy flow from one region to another, carrying with them the signatures of their origins. This ancient visitor shows us that planetary formation elsewhere in the galaxy follows similar principles to our own, yet with variations that suggest countless unique worlds. If 3I Atlas formed in one stellar system, then similar objects must have formed in thousands, millions, billions of others. Each one is a potential carrier of information, a potential witness to distant creation. As we observe 3I Atlas through our telescopes, we are not simply studying a comet. We are reading a chapter from a cosmic history book, written in a language that predates our species, our sun, and our galaxy's current configuration. We are connecting with something ancient, something distant, something that reminds us of our humility within the universe. The significance of 3I Atlas extends beyond mere scientific curiosity. It speaks to our fundamental desire to understand our place in a vast cosmos. It suggests that we are not alone in our corner of space, that other stellar systems have their own stories, their own histories, their own mysteries waiting to be discovered. As this ancient visitor continues its journey through our solar system, it carries with it the answers to questions we have not yet learned to ask. It is a reminder that the universe is far more complex, far more interconnected, and far more wondrous than we often imagine. Imagine standing in an observatory on a clear night, your eye pressed against a telescope's lens. What you see is not a distant star, but something far more precious, a visitor from another world, traveling through our cosmic neighborhood at speeds that defy our everyday understanding. This is where science transforms into wonder. The telescopes that reveal 3I Atlas are marvels of human ingenuity, each one a bridge between our small planet and the infinite expanse beyond. These instruments do not simply magnify light. They capture stories written in photons, translate cosmic whispers into data we can understand. The technology that detected this ancient comet began with a question humanity asked centuries ago: what lies beyond the visible? In the 17th century, Galileo first pointed a simple telescope toward the heavens. Today, we possess instruments so sensitive they can detect the faintest glow from objects billions of miles away. The Panoramic Survey Telescope and Rapid Response System, which discovered 3I Atlas, represents the culmination of generations of astronomical innovation. These modern telescopes work through a principle as elegant as it is profound. They gather light that has traveled through the void of space for years, decades, sometimes longer. Every photon that enters the lens carries information encoded in its wavelength, its intensity, its polarization. Astronomers have learned to read this cosmic language with extraordinary precision. When 3I Atlas was first observed, it appeared as a faint smudge against the background of stars. But this smudge told a story. Its brightness, its color, the way it moved across the sky night after night, all revealed something extraordinary. Spectroscopy, a technique that breaks light into its component colors, showed signatures of elements and molecules never before seen in our solar system's comets. Imagine light as a fingerprint. Every substance, when heated or illuminated, produces a unique pattern of light and darkness. Hydrogen glows at specific wavelengths. Carbon does the same. Water, ice, dust, complex organic molecules all leave their marks on the spectrum. When astronomers examined 3I Atlas through spectroscopic analysis, they discovered ratios and compounds that simply did not match anything from our neighborhood. The hyperbolic trajectory we discussed earlier was confirmed through careful observation and mathematical calculation. Telescopes tracked the comet's position night after night, month after month. Each observation refined the calculation of its path. The mathematics revealed what seemed impossible at first. This object was not bound to our sun. It was passing through, following a path that would carry it away forever. This discovery required more than one telescope. Astronomers across the world coordinated their observations. In Hawaii, in Chile, in Europe, in Japan, telescopes turned toward the same point in the sky. This global network of observation provided redundancy, confirmation, and depth of understanding that no single instrument could achieve alone. The infrared telescopes proved particularly valuable. While visible light telescopes see what our eyes might see through a powerful magnifying lens, infrared instruments detect heat and longer wavelengths. 3I Atlas, being cold and distant, emits much of its radiation in the infrared spectrum. These observations revealed the comet's composition with remarkable clarity. The presence of water ice, carbon dioxide, and complex organic molecules emerged from the thermal signatures captured by space-based infrared observatories. Consider the James Webb Space Telescope, humanity's most advanced eye on the cosmos. Though primarily designed for observations of the early universe, such instruments have contributed to our understanding of interstellar visitors. These telescopes operate beyond Earth's atmosphere, free from the distortions caused by air and weather. They see with a clarity that ground-based telescopes, no matter how powerful, cannot match. Radio astronomy added another dimension to our knowledge. By observing the radio waves emitted or reflected by 3I Atlas, scientists detected the presence of volatile compounds and mapped the comet's coma, the cloud of gas and dust surrounding its nucleus. This technique, which seems almost magical, allows astronomers to understand the composition and structure of distant objects without ever leaving Earth. The data collected by these various instruments flows into supercomputers. These machines process millions of observations, perform complex calculations, and help astronomers construct three-dimensional models of the comet's structure and composition. The computational power available today would have seemed like pure science fiction just decades ago. Yet technology alone does not reveal truth. Behind every telescope, every spectroscope, every detector stands a human mind asking questions. Why does this object move this way? What do these light signatures mean? How does this evidence fit into our understanding of the universe? The technology provides the eyes, but curiosity provides the direction. The discovery of 3I Atlas represents a moment when human technology finally became sophisticated enough to detect and study objects from beyond our solar system. For millennia, we could only imagine what lay beyond our cosmic neighborhood. Now we can observe it, measure it, analyze it. This achievement connects directly to what makes this ancient visitor so significant. We can now reach across billions of years and billions of miles to touch, through light and data, the story of another star system. The technology that makes this possible is not separate from the science. It is science made manifest. As we observe 3I Atlas, we are witnessing the frontier of human understanding. Each observation, each measurement, each analysis pushes the boundary of what we know about our place in the cosmos. The comet itself remains unchanged, following its ancient path. But we, through our instruments and our curiosity, have transformed from passive observers of a distant point of light into active participants in a cosmic discovery. Where are you listening from right now? And as you contemplate this ancient visitor, this 7-billion-year-old messenger crossing our sky, do you feel the connection between our technology and the infinite? I'd like to know what draws you to these stories of the cosmos. Now that we understand how scientists observe this ancient traveler, let us explore what these observations actually reveal about its composition. 3 billion years before Earth formed, 3I Atlas was already drifting through the void. What it carries within its frozen body tells a story that reaches far beyond our solar system. Water exists everywhere in the universe. Yet the water locked inside 3I Atlas is not like the water in Earth's oceans. Scientists measure the ratio of hydrogen isotopes, deuterium to regular hydrogen, and find something remarkable. This ratio differs from what we see in our comets. This difference is a fingerprint. It whispers of a distant star, a system we have never visited, a place that shaped this object billions of years before we existed. Imagine ice as a library. Each frozen layer preserves information about the environment where it formed. The ammonia trapped within 3I Atlas speaks of temperatures and pressures found only in the outer regions of alien planetary systems. The methane frozen into its structure reveals something about the stellar radiation it experienced during its formation. These chemicals are not random. They are signatures. They are evidence. The organic molecules discovered on 3I Atlas add another layer to this cosmic story. Complex carbon-based compounds, some containing nitrogen and oxygen, suggest chemical processes that occurred in the presence of stellar radiation and cosmic rays. These are the building blocks of life as we understand it. Not life itself, but the raw materials from which life might emerge. This ancient visitor carries the chemistry of creation itself. I'd like to know, where are you listening from, and what time is it there? As you sit with this knowledge, imagine the vast distance this object traveled. Every molecule we detect has journeyed through the darkness for 7 billion years, carrying messages from a star system whose name we will never know. The trajectory of 3I Atlas reveals something equally profound. Scientists calculate its path using gravitational models and orbital mechanics. This comet did not arrive randomly. It entered our solar system on a hyperbolic orbit, a path that curves but never closes, never settles into a stable loop. This means it will leave us. It will pass through our system once and then continue into the infinite darkness beyond, never to return. This is the nature of interstellar visitors. They are travelers, not residents. They pass through our home like visitors in the night. The speed at which 3I Atlas moves tells us something about the gravitational environment of its home system. Objects moving faster were likely born farther from their parent star, where gravitational pull was weaker. Objects moving slower suggest origins closer to intense stellar radiation. The velocity of 3I Atlas, combined with its chemical composition, creates a puzzle that astronomers are still solving. Each piece of data adds clarity to a portrait of a world we have never seen. Consider the heating this object experiences as it approaches our sun. Billions of years in the cold void, and suddenly it enters a region where stellar radiation intensifies. The surface begins to sublimate. Ice transforms directly into vapor without becoming liquid. This creates the tail we observe through telescopes. This glowing trail is not the comet itself. It is the comet's farewell. It is material being stripped away, molecules being released into space, creating a luminous wake that stretches across millions of kilometers. The dust particles released from 3I Atlas differ from the dust found in our solar system's comets. Analysis shows mineral compositions that suggest formation in different temperature conditions under different stellar winds. In an alien planetary nebula, each dust grain carries isotopic ratios that match no known solar system source. They are truly foreign. They are truly other. This is where science becomes contemplative. We hold these grains of dust, metaphorically, through our instruments, and we hold something that formed in another star's embrace. We touch, through observation and analysis, a world that orbits a sun we cannot see. We connect with a planetary system that may have harbored its own worlds, its own possibilities, its own stories. The organic chemistry preserved in 3I Atlas suggests that the processes creating complex molecules are not unique to our solar system. They are universal. Wherever stellar radiation meets simple chemicals in the cold of space, complexity emerges. This means the chemistry of life, the building blocks of biology, exists throughout the cosmos. Not everywhere, perhaps, but in countless places, in countless systems, orbiting countless distant stars. The implications are profound and gentle at once. We are not unique in our chemical foundation. The atoms that form our bodies have cousins throughout the universe. The molecules that enable our existence are common. This is both humbling and beautiful. It suggests that life, if it emerges elsewhere, would be built from similar foundations. It would be recognizable in its chemistry, even if its forms remain unimaginable to us. As 3I Atlas continues its journey through our solar system, it brings us closer to understanding our place in a much larger cosmos. It reminds us that the boundary between our solar system and the rest of the universe is not absolute. It is permeable. Objects flow across it. Information flows across it. We are not isolated. We are part of a vast interconnected whole. The study of this comet is therefore the study of ourselves. When we analyze the water in 3I Atlas, we are learning about water throughout the universe. When we measure its organic molecules, we are measuring the common chemistry of creation. This ancient visitor has traveled 7 billion years to teach us something essential. We belong to a cosmos far larger and more complex than we could ever imagine, yet fundamentally connected to every corner of it. Imagine standing at the edge of a vast neighborhood. Beyond your house lies an invisible boundary, a threshold where the familiar ends and the unknown begins. This is where our solar system meets the cosmos, and it is here, crossing this ancient threshold, that visitors like 3I Atlas arrive. Our solar system is not a closed fortress. It is more like a gentle sphere with permeable edges, where the influence of our sun gradually fades into the darkness of interstellar space. This boundary is called the Oort cloud, a theoretical shell of icy bodies that marks where our sun's gravity still holds sway. Beyond it stretches the realm of other stars, other systems, other worlds we may never see. The Oort cloud exists roughly 50,000 astronomical units from our sun. To put this in perspective, 1 astronomical unit is the distance from Earth to the sun. 50,000 times that distance creates a sphere so vast that light from our sun, traveling at its incredible speed, takes nearly a year to reach its outer edge. Within this cloud drift billions upon billions of icy remnants, silent witnesses to our solar system's birth. These icy bodies have drifted there for 4.5 billion years, undisturbed and frozen in time. They are relics of our system's formation, ejected outward when planets shifted their orbits. They orbit so slowly, so distantly, that they seem almost stationary. Yet they are not prisoners. They are travelers waiting for a gravitational nudge that might send them inward toward the sun or outward into the depths of space. This is where the story becomes profound. Stars do not travel through space alone. They move through vast clouds of gas and dust, through regions dense with other stellar systems. When our sun journeys through these cosmic neighborhoods, its gravity can capture passing objects, or conversely, lose its grip on distant ones. The Oort cloud represents the frontier where this cosmic exchange occurs. 3I Atlas entered our solar system from beyond this boundary. Its trajectory tells us it came from interstellar space, traveling through the darkness between stars for millions of years before crossing into our system's gravitational embrace. This crossing was not violent. It was gradual, a gentle capture by our sun's distant pull. The comet was traveling at a speed relative to our sun that indicated its alien origin, a velocity impossible for any object born within our solar system. The significance of this boundary cannot be overstated. For centuries, humans believed the solar system was isolated, a complete and self-contained realm. We imagined our system as an island in an infinite ocean. But the arrival of interstellar visitors reveals a different truth. Our system is part of a larger community. It exchanges material with other systems. It shares its space with wanderers from distant stars. When 3I Atlas crossed this threshold, it brought with it a record of its journey. The molecules within its nucleus, the dust coating its surface, the water ice embedded in its structure, all carry signatures of the stellar system that birthed it. These signatures are like fingerprints, unique and identifiable. They tell us about conditions in a distant system, about processes that unfolded around another star billions of years ago. Scientists study this boundary not merely to understand comets, but to understand how the universe itself functions. The Oort cloud is a gateway. It is where the local and the cosmic meet. It is where we can study material from other systems, without traveling to other stars. Each interstellar visitor brings a sample of the universe to us, a gift carried across the void. The detection of such visitors required us to expand our understanding of what the solar system truly is. It is not a rigid sphere with fixed boundaries. It is a dynamic system, constantly exchanging material with its neighbors. Comets leave, comets arrive. The solar system breathes, in a sense, exchanging molecules with the cosmos around it. This breathing motion has profound implications. It suggests that the chemistry enabling life is not unique to our system. It suggests that the building blocks of life travel between stars. Water, organic molecules, complex compounds. These are not rare treasures confined to Earth. They are common travelers throughout the galaxy, hitchhiking on comets and asteroids, seeding the cosmos with the potential for life. When you look at the night sky and see a faint star in the distance, remember that the space between you and that star is not empty. It is filled with wandering objects, with icy travelers on journeys lasting millions of years. Some of these travelers will eventually cross the boundary into our solar system. Some will pass near Earth. Some will disappear into the sun. But each one carries a story, a record of where it came from and what the universe is truly like. The boundary of our solar system is not a wall. It is an opening. It is a place where the universe reveals itself to us, where distant worlds send their messengers to teach us about the cosmos. 3I Atlas is one such messenger. Its presence at this threshold reminds us that we are not isolated, not alone in the universe. We are part of a living, breathing cosmos, where matter flows between systems, where the chemistry of life circulates like a cosmic wind. Where are you listening from right now? What time is it in your location? I'd like to know as we continue this journey together through the universe's most profound mysteries. When light travels through space, it carries stories. Every photon that reaches our telescopes has journeyed across unimaginable distances, carrying information encoded in its wavelength. This is spectroscopy's silent language, and through it, we listen to whispers from 7 billion years ago. Imagine standing in absolute darkness. A distant star emits light, and that light passes through a cloud of gas and dust. Some wavelengths are absorbed, others pass through. When that light finally reaches Earth, it bears the fingerprint of every element it encountered during its cosmic journey. This is how we read the universe. 3I/Atlas speaks to us in this ancient language. When astronomers pointed their most sensitive instruments toward this visitor, they didn't just measure its brightness or position. They broke its light into a spectrum, like a prism revealing hidden colors within white light. Each color corresponds to a specific wavelength. Each wavelength tells us about a specific element or molecule present in the comet. The spectroscopic analysis revealed something profound. Cyanide, carbon monoxide, water vapor, and complex hydrocarbons all left their signatures in the light. But here is what makes this discovery remarkable. The ratios of these molecules are different from what we find in comets born within our own solar system. Think of it this way. Every stellar nursery has its own chemical recipe. When planets and comets form around a star, they inherit that particular stellar kitchen's ingredients and proportions. Our solar system's comets carry the chemical fingerprint of our sun's neighborhood 4.5 billion years ago. But 3I/Atlas carries a completely different recipe. The abundance of certain isotopes proved decisive. Isotopes are atoms of the same element with different numbers of neutrons. They have slightly different masses. When spectroscopy measures the light absorbed by these isotopes, it detects subtle shifts in wavelength. These shifts revealed that 3I/Atlas contains isotope ratios unlike anything in our planetary neighborhood. This discovery opened a window into a distant stellar system. Somewhere in the galaxy, perhaps 7 billion years ago, a young star was surrounded by swirling gas and dust. Planets formed, comets condensed from that primordial material. One of those comets was eventually ejected from its home system, perhaps by gravitational encounters with massive planets. It entered interstellar space and began its solitary journey through the dark. For billions of years, this comet traveled alone through the void. It passed near other stars. It drifted through regions where no light reached it. Then, by the slimmest probability, its path curved toward our solar system. The gravitational influence of our Sun bent its trajectory. It crossed the Oort cloud. It entered the inner solar system, and there our telescopes found it. But spectroscopy revealed even more. The light from 3I/Atlas showed something unexpected in its molecular composition. Certain organic molecules were present in concentrations that suggested they formed in conditions we associate with liquid water environments. This implies that in the comet's parent system, there may have been a period when this object experienced warmth, perhaps from a nearby star or from internal radioactive decay. These conditions would have allowed chemical reactions. Simple molecules would have combined into more complex ones. The building blocks of life as we understand it would have assembled themselves. Then, as the comet drifted into the cold void, these molecules froze in place, preserved like insects in amber, waiting billions of years to be discovered. The spectroscopic language also revealed something about the comet's surface. The light reflected from its outer layers showed patterns consistent with a mixture of water ice, rock, and organic material. But the distribution of these components was uneven. Some regions reflected light differently than others, suggesting variations in composition across the comet's surface. This heterogeneity tells a story of cosmic violence. The comet likely experienced collisions during its formation in its home system. Perhaps it was struck by other planetesimals. Perhaps it was fragmented and then reassembled by gravity. Each impact would have mixed different materials, creating the varied surface we observe today. Now, as this visitor approaches our Sun, the heat increases. The ice begins to sublimate. Molecules that have been frozen for 7 billion years transform into gas and dust. They form the coma, the glowing cloud surrounding the comet's nucleus. They form the tail, streaming away from the Sun. And as this happens, spectroscopy continues to listen. Each moment, the light changes. New molecules appear in the spectrum as different ices melt. The ratios shift. The story becomes more detailed. We are reading the comet's biography, written in light, one wavelength at a time. This ancient visitor from another star system is teaching us something profound. It is showing us that the chemistry of life is not unique to Earth. It is not even unique to our solar system. It is written into the fabric of the universe itself. Wherever conditions allow, these molecules form. Wherever there is time and chemistry, complexity emerges. The light from 3I/Atlas, captured by our instruments and decoded by patient scientists, reminds us that we are not isolated. We are connected to distant stellar systems through these cosmic messengers. The molecules that make up our bodies were once part of a comet like this one. They traveled through interstellar space. They arrived here. They became part of our world. And now, this new comet brings us gifts from another home, another star, another chapter of the universe's unfolding story. Through spectroscopy's silent language, we listen to what it has to tell us. Now we arrive at something profound. This ancient visitor is not merely a relic of distant space. It is a teacher, a messenger carrying lessons about how worlds themselves are born. When astronomers first analyzed the chemical composition of 3I/Atlas, they noticed something unexpected. The ratios of certain elements did not match our solar system's signature. Our planets formed from a single cloud of dust and gas, all sharing the same cosmic recipe. But this comet came from elsewhere. Its elements tell a different story of creation. Think of it this way. Every stellar system is like a kitchen with its own ingredients and proportions. Our solar system's kitchen mixed hydrogen, helium, and heavier elements in specific amounts. But 3I/Atlas arrived from a different kitchen, a kitchen that existed 7 billion years ago, far from our Sun. Scientists now understand that planetary formation follows universal patterns, yet each system develops unique characteristics. When a young star forms, it is surrounded by a rotating disk of material. Dust particles collide gently, sticking together. Small grains become pebbles. Pebbles become boulders. Boulders become planetesimals. And planetesimals eventually become worlds. But the speed of this process depends on the initial composition. If a stellar system has more metals, astronomers call heavier elements metals, planets form faster and differently. If a system has less, formation takes longer and creates different architectures. The comet in our sky right now carries evidence of how its home system assembled itself. This is where our understanding transforms. For decades, scientists assumed all planetary systems followed similar paths because we only knew our own. We studied our 8 planets, our asteroid belt, our distant Kuiper belt. We built models based on this single example. But 3I Atlas suggests something revolutionary. It shows us that planetary formation is more flexible, more creative than we imagined. The comet's preserved ices contain trapped gases. These gases are like time capsules. They reveal the temperature and pressure conditions when the comet formed. Scientists can read these conditions like pages in an ancient book. The story they tell is of a system where planets assembled under different circumstances than ours. Consider the spacing of planets in any system. Our inner planets are close to the Sun. Our outer planets are far away. This arrangement emerged from specific gravitational interactions during formation, but other systems show different patterns. Some have massive planets orbiting very close to their stars. Others have planets in unusual elliptical orbits. These variations suggest different formation histories. 3I Atlas provides direct evidence of one such alternative history. By studying its composition, we learn that its home system likely had a different planetary architecture. Perhaps its planets formed in different locations and then migrated. Perhaps collisions reshaped the system after formation. Perhaps the stellar winds were stronger or weaker, affecting how material accumulated. This knowledge matters deeply. It tells us that the universe is not monotonous. It is not simply repeating our solar system billions of times. Instead, each stellar system is unique. Each follows universal physical laws, yet each creates its own particular arrangement of worlds. Now imagine what this means for the search for life. We have long assumed that habitable planets must resemble Earth. They must orbit at the right distance from their star. They must have liquid water. They must have certain chemical compositions. But if planetary systems are more diverse than we thought, then habitable worlds might exist in unexpected configurations. The comet teaches us that life's chemistry is robust and widespread. Water exists in distant systems. Organic molecules form naturally. The building blocks of life travel through space itself. Combined with our new understanding of planetary diversity, this suggests that habitable worlds might be far more common than we previously calculated. Scientists now study 3I Atlas with renewed intensity. Every measurement, every spectral line, every chemical analysis adds to our understanding. The comet has become a bridge between our solar system and the distant cosmos. Through it, we learn that creation is not limited to a single template. The universe builds worlds in many ways. There is something humbling in this realization. For centuries, humans believed Earth was the center of everything. Then we learned we orbit the Sun. Then we learned our Sun is one of billions. Now we learn that even our planetary system's formation is not the universal standard. We are learning to see ourselves not as the model, but as one example among countless variations. Yet there is also something beautiful here. This diversity suggests resilience. If worlds form through many pathways, if chemistry assembles life's ingredients in different ways, then existence itself is robust. The cosmos is not fragile, it is creative, it is abundant. The comet continues its journey through our solar system, already beginning its departure. It will never return. But what it has taught us will remain. We now know that the universe is far stranger and more wonderful than our single example suggested. We know that planetary formation is an art as much as a science, and we know that somewhere in distant systems, under different stars, other worlds are being born through their own unique processes. This knowledge changes how we see our place in the cosmos. We are not the only way worlds form. We are not the only way life's chemistry assembles. We are part of a vast creative universe that builds existence in infinite variations. The orbital path of 3I Atlas tells a story that words alone cannot capture. Imagine tracing a line through space so vast that our entire solar system becomes merely a speck along its journey. This comet does not orbit in the gentle, predictable circles we see in our planetary neighborhood. Instead, it follows a hyperbolic trajectory, a mathematical curve that speaks of freedom and distance, of a visitor that will never return. Orbital mechanics are the language of the universe. They reveal not just where an object is, but where it came from and where it is going. When astronomers first calculated 3I Atlas's path, they discovered something profound. The comet's trajectory was not bound to our sun's gravity. This is the signature of an interstellar wanderer, a body that belongs to no single star, but to the cosmic void itself. The mathematics behind this discovery is elegant in its simplicity. A hyperbolic orbit means the comet's speed exceeds what we call escape velocity, the minimum speed needed to break free from a star's gravitational pull. As 3I Atlas approaches our sun, it accelerates, reaches its closest point, then continues outward, never to curve back. This is different from comets born in our Oort cloud, which follow elliptical paths and return across millennia. What does this tell us about distant stars? Everything. The orbital mechanics of 3I Atlas are clues to how other stellar systems function. When we study this comet's path, we are reading a message written in gravity and motion, a message that speaks of a system far away that ejected this body into the cosmic sea. Consider the forces at play. When a comet forms near a star, gravitational interactions with planets can fling it outward. Imagine a game of cosmic billiards where a planet strikes a comet with invisible hands, sending it spinning into the darkness. In 3I Atlas's home system, something similar occurred billions of years ago. A planetary encounter, a gravitational dance, created the conditions for this comet to escape. The velocity of 3I Atlas holds another secret. Astronomers measured how fast this comet moves through space, and the number revealed something unexpected. The comet's speed suggests it was ejected from a system with multiple massive planets, worlds far larger than Earth. These giant worlds would have possessed the gravitational strength needed to launch a comet at such tremendous velocity. This discovery reshapes our understanding of planetary architecture. We now know that systems with giant planets are not rare anomalies but common arrangements. When we observe 3I Atlas's trajectory, we see evidence of a system that resembles our own Jupiter and Saturn, yet formed under different conditions, in a different place, at a different time. The angle at which 3I Atlas approaches our solar system also matters. It does not come from any single direction, but from a region of space that suggests it traveled through the galactic disk for billions of years. The comet's path intersects ours at a point that seems almost random, yet this randomness itself is revealing. It suggests that interstellar visitors arrive from all directions, that our solar system is constantly bombarded by material from distant stars. Advanced technology allows us to calculate not just where 3I Atlas came from, but approximately when it left its home system. By analyzing the comet's composition and considering the rate at which cosmic radiation alters its surface, scientists estimate this visitor has been traveling for several billion years. It witnessed the formation of our solar system from afar, a silent observer crossing the void, while Earth itself was still being born. The gravitational influence of planets in our solar system also affects 3I Atlas's path. As the comet approaches Jupiter or Saturn, these massive worlds slightly alter its trajectory. This phenomenon, called gravitational assist or swing-by, is the same principle NASA uses to send spacecraft to distant planets. In 3I Atlas's case, our planets are gently redirecting this ancient visitor, pulling it into a new trajectory as it leaves our neighborhood. This interaction reveals something beautiful about the interconnectedness of the cosmos. Even as 3I Atlas passes through our solar system, it exchanges gravitational influence with our worlds. In a real sense, our planets are communicating with this distant visitor, leaving marks upon its path that will persist for billions of years into the future. The orbital mechanics of 3I Atlas also help us understand what happens to other interstellar objects. Astronomers now suspect that countless comets and asteroids like 3I Atlas drift through the galaxy, most passing undetected through our solar system. We have simply become good enough at observing to notice them. Each one carries information about its home system. Each one is a messenger bearing witness to distant stellar architecture. Where are you listening from right now? I wonder if you are imagining this comet's journey, this 7 billion-year voyage through the darkness. Take a moment to consider the scale. The distance this comet has traveled is so vast that human language fails to describe it. Yet through orbital mechanics, through the elegant mathematics of gravity and motion, we can read its story. The architecture of distant stars becomes visible when we study objects like 3I Atlas. We cannot visit those stars ourselves, cannot send telescopes to observe their planetary systems directly. But when an interstellar comet arrives, it brings data with it. Its orbit, its speed, its composition, all combine to paint a portrait of a world we will never see. This is the gift of orbital mechanics. This is how the universe speaks to us across the incomprehensible distances of space. 3I Atlas's hyperbolic path is not merely a mathematical curve. It is a story written in gravity, a testament to the diversity of worlds beyond our reach, a reminder that our solar system is not isolated, but part of a vast community of stars constantly exchanging visitors and messages. As this ancient comet continues its journey outward, it will carry with it the gravitational signatures of our planets, the marks of our solar system. In this way, we too are sending a message back to the distant star from which 3I Atlas came. The universe is a conversation conducted across billions of years and impossible distances, and we are only now learning to listen. Time moves differently when you hold something ancient in your hands. Not literally, of course, but when scientists examine the data streaming from 3I Atlas, they are touching moments frozen 7 billion years ago. This visitor carries within it the memory of worlds we have never seen, and through its presence, we are learning to read the language of deep time itself. Consider what this means. The atoms composing this comet were assembled in a stellar nursery incomprehensibly distant from our sun. They traveled through the darkness for eons, survived the chaos of planetary formation in an alien system, and then were ejected into the void by gravitational forces we can only imagine. Now in our present moment, they have arrived at Earth. Past and present have collided, and in that collision lies profound knowledge about how the universe creates worlds. The technologies we use to study 3I Atlas are themselves bridges across time. Spectroscopy, which we explored earlier, does not merely analyze light. It decodes the very history written into that light. When we observe the infrared signatures of water ice on this comet's surface, we are witnessing molecules that have remained essentially unchanged since the formation of its home system. These frozen waters preserve chemical ratios that tell us about the temperature, pressure, and composition of that distant stellar nursery, billions of years before our own sun ignited. This is where the practical becomes poetic. Advanced telescopes like the James Webb Space Telescope can now detect heat signatures from objects so distant and so faint that previous generations of astronomers could only imagine them. The technology required to observe 3I Atlas in detail represents centuries of human curiosity, crystallized into instruments of remarkable sensitivity. Each observation adds another layer to our understanding, another thread in the tapestry connecting us to the cosmos. But here is something equally profound. The data we gather from 3I Atlas allows us to refine our models of planetary formation not just in distant systems, but here at home. By understanding how this comet assembled itself 7 billion years ago, we gain insight into how our own solar system must have formed. The principles of physics that governed the creation of worlds in that alien system also governed the creation of our world. Time has separated these events by billions of years, yet the laws binding them remain constant. Imagine scientists in laboratories around the world comparing the chemical composition of 3I Atlas with meteorites that have fallen to Earth from our own solar system's early history. These meteorites, preserved in museums and research collections, are themselves ancient travelers. Some are 4.5 billion years old. When you place the data from 3I Atlas beside these terrestrial samples, differences emerge that are deeply meaningful. The ratios of certain isotopes, the presence of particular organic compounds, the crystalline structure of minerals, all these differences whisper stories about two separate worlds, two separate histories of creation. This comparison becomes a mirror. By understanding what makes 3I Atlas different from our own solar system's primordial material, We understand what makes our system unique. Perhaps our planetary system formed in a denser stellar cluster. Perhaps the massive planets in our neighborhood had different orbital configurations. Perhaps the stellar winds from our young sun shaped the early formation process in ways that had no parallel in the system that birthed 3I Atlas. Each difference is a clue, a piece of evidence in an investigation spanning billions of years. The practical applications extend further still. Space agencies and private space companies are already considering missions to study interstellar objects more closely. The next visitor, like 3I Atlas, might arrive carrying data that transforms our understanding of habitability, of the distribution of water and organic molecules throughout the galaxy, of the prevalence of planetary systems, similar to or radically different from our own. Each such visitor is an unmanned spacecraft sent from the depths of space, carrying gifts of knowledge if we possess the technology and patience to unwrap them. Yet technology alone is insufficient. We must also cultivate the philosophical patience to truly comprehend what these discoveries mean. When we recognize that 3I Atlas carries within its nucleus the history of a world we will never visit, we are forced to expand our sense of connection to the cosmos. We are not isolated observers in a dead universe. We are participants in a continuous exchange of material and energy with the wider galaxy. Comets like 3I Atlas are the messengers of this exchange, the living proof that all worlds are part of a single, vast, interconnected system. This recognition transforms how we understand our place in existence. The atoms in your body were once part of stars. The water you drink contains hydrogen forged in the Big Bang itself, and now, through the study of interstellar visitors, we understand that the boundaries between our solar system and the wider galaxy are far more permeable than previously imagined. Matter flows between systems. Information travels on waves of light. Time itself becomes a bridge, connecting the ancient past of distant worlds to our present understanding. As we move toward the final reflections of this journey, hold this thought gently. Every moment of scientific discovery is also a moment of profound connection. When we study 3I Atlas, we are not merely cataloging data points. We are reading the autobiography of the universe itself. Written across billions of years and millions of light years of distance, the visitor from the stars has arrived, and through patient observation and thoughtful interpretation, we are learning to understand what it has come to tell us. As we stand at the threshold of understanding what 3I Atlas has revealed, a deeper question emerges from the cosmic silence. What comes next? The discovery of this ancient visitor has fundamentally altered how we prepare for future encounters with the interstellar medium. Scientists across observatories worldwide are now refining their detection methods, knowing that more messengers from distant systems may already be traveling toward us through the vast emptiness. The technology that decoded 3I Atlas's 7-billion-year-old secrets is evolving rapidly. Ground-based telescopes equipped with adaptive optics now peer deeper into the night sky with unprecedented clarity. Space-based instruments continue their patient vigil, scanning for thermal signatures that betray the presence of incoming objects. Each new visitor teaches us something invaluable about the universe's architecture, about how systems far from our own have assembled their worlds and seeded their spaces with remnants of creation. Imagine the next interstellar comet arriving in 15 years, or perhaps 50. When it does, we will be ready in ways previous generations could never have been. The lessons from 3I Atlas have created a template for understanding. We now know what chemical markers to seek, what orbital patterns to recognize, what stories the composition of ice and dust can tell us about worlds we may never visit directly. But preparation extends beyond technology. It reaches into how we think about our place in a living cosmos. Each interstellar visitor is not merely an object to study. It is a messenger, a bridge connecting us to the vast network of stellar systems scattered throughout our galaxy. When the next comet crosses our path, we will greet it with humility and curiosity, knowing that within its frozen structure lies information about planetary formation, about the diversity of worlds, about the fundamental processes that create habitable environments across the universe. The search continues, not because we are searching for something we have lost, but because we are searching for something we have yet to understand. Future visitors will arrive carrying their own secrets, their own chemical compositions encoding stories of collision and creation billions of years in the past. Some may contain organic compounds, the building blocks of life itself. Others may reveal planetary systems more exotic than anything we have yet imagined, with configurations that challenge our theoretical models and expand the boundaries of what we thought possible. Scientists are already designing new detection networks. Space agencies collaborate across borders, sharing data and insights. The discovery of 3I Atlas has unified the global scientific community in a shared purpose. We recognize that these cosmic visitors do not belong to any single nation or institution. They belong to all of us, to humanity as a whole, and they carry messages written in the language of chemistry and physics that transcends all boundaries. Consider what we have learned through this single encounter. We know now that planetary systems can assemble in radically different ways. We understand that the ingredients scattered through space vary from system to system, creating worlds of infinite diversity. We have glimpsed the mechanics of how gravity sculpts orbits across billions of years, sending objects on trajectories that eventually cross our path. And we have developed tools capable of reading the biography of matter older than our own sun. The future holds more than new comets. It holds the possibility of detecting objects even more ancient, perhaps remnants from the earliest epochs of our galaxy. It holds the promise of finding materials that have never been processed through a star's furnace, pristine samples of the primordial cosmos. Each discovery will refine our understanding further, adding new details to the portrait of a universe far richer and more complex than we previously imagined. Where are you listening from right now? And as you rest in this moment, consider what it means to live on a world that receives these cosmic visitors. We are not isolated. We are part of an interconnected universe where matter travels across the vast distances between stars, where information encoded in ice and dust can travel for billions of years to reach us, to teach us, to transform how we see ourselves and our place in creation. The search continues because the universe is infinite in its complexity and generosity. Future visitors will arrive, and we will be ready to listen. We will decode their messages, learn their stories, and add their knowledge to the ever-growing tapestry of cosmic understanding. 3I Atlas was not an ending. It was an invitation, an opening of a door that reveals an entire universe of possibilities waiting to be explored. As we prepare for what comes next, we carry forward the wisdom this ancient comet has shared. We carry the knowledge that our solar system is not alone, that our way of building worlds is not the only way, and that the universe constantly communicates with us through these messengers from the stars. The future of astronomy is not merely about observing the cosmos. It is about engaging in a conversation with it, listening carefully to what each new visitor has to teach us about the infinite dance of creation that surrounds us. Rest now in the knowledge that we are part of something vast and beautiful. The next comet is already on its way, carrying with it secrets and stories waiting to be discovered. And we, as a species, are learning to listen. Close your eyes for a moment. Breathe slowly. Imagine standing on a vast shore where waves of starlight wash gently against the edges of your consciousness. This is where we find ourselves now, at the end of our journey with 3I Atlas, the 7-billion-year-old visitor that has carried us through time, space, and the deepest questions of existence. Throughout this exploration, we have witnessed something profound. A single comet, born in a distant stellar system before our sun even ignited, has become a mirror reflecting who we are and where we belong in the cosmos. It arrived not as a threat, but as a messenger, a living archive written in ice and stone. Think back to where we began. We stood at the threshold of discovery, watching this ancient traveler approach through the darkness. Its hyperbolic trajectory told us a story older than mountains, older than oceans, older than the very formation of our world. That curved path, that mathematical poetry, revealed something essential. We are not isolated. Our solar system breathes with the universe. It exchanges gifts with distant realms we have never seen. Then we descended into the chemistry of time itself. Those 7 billion years encoded in molecular structures became visible through our instruments and our understanding. We learned that this comet carries signatures from a different stellar nursery, a different corner of creation. When we compared its composition with meteorites in our laboratories, we recognized the profound truth that planets form through universal principles. Yet each system writes its own story in the language of atoms and elements. The journey taught us that technology is not merely a tool of observation. It is an extension of human curiosity, a bridge between the ancient and the present. Our telescopes and spectrographs are like fingers reaching across the void, touching the surface of mysteries older than our civilization itself. Every measurement, every spectrum, every data point is an act of communion with the cosmos. Yet perhaps the most beautiful revelation emerged as we looked forward. The universe is not finished speaking. More visitors will come. More messages will arrive in the form of comets and asteroids, each carrying pieces of the puzzle we are slowly assembling. We have learned to listen. We have built networks of detection and understanding. We are becoming fluent in the language of the stars. This is the true significance of 3I Atlas. It is not merely a scientific curiosity or an astronomical event. It represents a turning point in human consciousness. For millennia, we gazed upward with wonder but limited understanding. We told stories about the heavens, some poetic, some fearful. Now we possess the capacity to read those stories directly, to understand the physics and chemistry that write them. But knowledge brings responsibility. As we learn to decode the messages arriving from beyond our world, we must also contemplate what these discoveries mean for our place in existence. We are made of stardust, yes, but we are also observers, interpreters, seekers of truth. The atoms that compose our bodies were forged in stellar furnaces. The carbon in our cells has danced through galaxies. The oxygen we breathe has witnessed the birth and death of countless worlds. When we study a comet like 3I Atlas, we are studying ourselves. We are reading our own origin story written in the language of physics and chemistry. Every discovery about distant stellar systems teaches us about the processes that shaped our own world. Every analysis of an ancient visitor illuminates the journey that led to our existence. There is a quiet humility in this realization. We are neither the center of creation nor insignificant specks. We are conscious beings inhabiting a universe of breathtaking complexity and beauty. We possess the remarkable ability to understand our surroundings, to ask questions, and to seek answers. This capacity for wonder and comprehension is perhaps our greatest gift. As this 7-billion-year-old visitor continues its journey through our solar system, it carries something new now. It carries our questions, our curiosity, our desire to understand. It carries the imprint of human consciousness reaching across the void. In a sense, we have touched it, and it has touched us. The story of 3I Atlas reminds us that science and contemplation are not separate pursuits. They are intertwined threads in the same tapestry. When we observe the cosmos with instruments, we are also observing it with our hearts and minds. When we measure and calculate, we are also dreaming and imagining. The universe speaks to us in the language of mathematics and physics, but also in the language of beauty, mystery, and infinite possibility. Moving forward, new visitors will arrive. New questions will emerge. Our understanding will deepen and transform. But the fundamental truth will remain constant. We are part of an interconnected cosmos. Every atom, every particle, every wave of light connects us to distant stars and ancient comets. We are not separate from the universe, we are expressions of it, conscious and wondering. This is the reflection we find when we gaze into the cosmic mirror that 3I Atlas has held before us. We see our origins, our connections, our place in an infinite dance of creation and transformation. We see that science is not cold or distant, but intimate and profound. We see that the universe is not silent, but constantly communicating with those who have learned to listen. Thank you for joining me on this complete journey through time and space, through chemistry and philosophy, through the ancient past and the unfolding future. If this experience has brought you inner peace and expanded your sense of wonder about our cosmos, I would deeply appreciate a like and subscription to Relaxing Science. Your support helps us continue creating content that bridges science and contemplation. I invite you to share in the comments. What question about the universe troubles your mind most? What cosmic mystery calls to your curiosity? Let us know what you would like to explore together in future journeys. Through the stars, we are all listeners in this infinite conversation, and your voice matters in our shared discovery.